So now let's actually use CodePeer. So at this point, we're going to quickly jump into a demo, and we happen to have Gannett Programming Studio all set here, ready to run a project. This is the so-called Simple Desk Calculator project. It has some number of routines that are useful for doing a very simple kind of textual desk calculator. You type in a simple expression and it'll give you the answer. We're now going to analyze all of the source code of this simple desk calculator and have CodePeer give us its determination of where there might be problems in this code. And if we look now at the so-called CodePeer report, it's identified no problems that it is giving a high ranking, which would be things that it thinks are definitely bugs. There are 7 medium ranking issues that it's identified and 14 lower ranking issues. These are ones that you probably don't want to worry about right away, but if you got to the point where you've resolved all of your medium levels, then it makes sense to look at these. From CodePeer's point of view, high level messages are the ones that are quite likely to be of interest to you. 7, the medium ones, here we have 7 of them, are more likely of interest, and the low ones may be simply false positives because the CodePeer is picky and has to assume the worst under certain circumstances, or it may be problems that are in fact not a bug. They're doing what they're supposed to do. Maybe they're supposed to raise an exception at a given point, or not supposed to handle certain kinds of values. So if we look down here in the message locations window, we can see various messages. There's some from stack, there's some from tokens, and so on. We're just going to pick this first one, an array index check. And if we click on it, it will bring up the location in the source file where that problem has been identified. And if we read what it's basically saying, it's telling us that we are getting a string, a next token, if you will, from the function next word, and then we're immediately looking at the first character of that word. So that seems fine. However, there is a problem. What happens if this string is the empty string? Then at this point, there will be a runtime failure because we're indexing into an empty string and it doesn't have any elements, so the standard ADA index checks will complain. And CodePeer is indicating this is a place where we might have a failure because from its point of view, next word might return an empty string. So this is an interesting situation where CodePeer is showing its ability to analyze not just a single subprogram, but what happens when one subprogram calls another subprogram, it returns a result, and so on. And that's a pretty important capability for any static analysis tool. In CodePeer, as mentioned earlier, preconditions and postconditions are computed for every subprogram in a bottom-up fashion so that when we get around to doing the call on nextword in this case, we've already learned something about nextword. So let's go look at nextword. We'll look at the body of nextword, which is where CodePeer has placed what we described before as built documentation. And this is really one of the key features of CodePeer. If you notice over here on the left, these are the line numbers in this source file input.adb. And there are no line numbers here because the programmer didn't write these comments. These comments were generated by CodePeer as a side effect of analyzing the algorithm of this function nextword. And there are various useful pieces of information here. First, of course, the name of the subprogram. It's within this package input. Here we are identifying what global variables are inputs to this function, and these inputs could have been read directly within here. So use of first char, last char line, and so on. We're using line. We may not actually be using last char in here, and so that's interesting. Who is using last char? It turns out that last char is referenced inside skip spaces. So this is a roll-up, if you will, of the uses of global variables by nextword itself or by anything it calls. So this can be very useful information when you're doing code review or just generally information flow. Where is this global variable being manipulated? CodePeer has provided information. Furthermore, for global variables, you really often want to know, well, who is updating them? And this is saying that these global variables are potentially global outputs of this subprogram. Then here's the part which is truly unique to CodePeer. It is inferring limitations, inferring what we call preconditions based on the algorithm. These are limitations that are telling us that if you violate one of these, there's a chance that the subprogram may fail. Postconditions are where CodePeer is summarizing the net effect of this subprogram, of this function. And it can tell you that it may be initializing various objects. And in terms of these globals, it's telling you something about their final value. That is, after this is done, you can be certain that this global variable will be less than 1024, last char will be greater than or equal to 1, and so on. One of the most interesting things is if there are outputs, it also tells you what are the properties of those outputs. And it could tell you both in terms of a formula, or it could tell you in terms of just a range of values. And the one we're actually interested in right now is result, which is the string being returned. Next word tick result is the way that CodePeer refers to the result of a string. This is also the way it's referred to in Ada 2012 postconditions. And we're able to characterize the properties of that string. Here we're saying that the low bound of the string, that first will always be less than 1024, so that's useful to know. And the high bound will be in the range 0 to 1023. This is the thing I was hoping to find out. It's telling us that there is the possibility from CodePeer's analysis that the resulting string might be an empty string. So if we go back here, if it's an empty string, sure enough, this would fail. So there are various ways we can deal with it. The simplest, which we'll do for now, is we'll insert a little test here. We'll say that if word tick length equals 0, then, well, let's raise some kind of exception. And if we look down below, the exception that we're raising in case the input is bad, which is sort of what we're claiming right now. This is implying a bad input. We'll raise this user error. So we're basically saying that the user gave us some bad input. We'll see later that perhaps that's not actually the problem, but this will at least show us that if we insert this kind of a defensive coding, let's say, prevent us even reaching this if there is a zero length string, then CodePeer will now recognize that we have ensured that we won't reach this with a bad value, and we can prove that by, let's just mark this as being part of our demo so we remember to remove it later so we don't just leave behind this extra code that we've added when we want to restore this to its original state. Okay, so we're going to save that. Then we're going to reanalyze this little piece of code. And you can see there's a little progress bar over here. And now things have changed. And one of the things that we can find out exactly what has changed by looking at, we're interested in messages that have been removed. And sure enough, one message of medium level has been removed. And it's a little hard to read it, but it says that the one that's been removed is this one we were worried about. If we click on it, we'll show that, there's no longer a orange bar here. CodePeer has determined that this will not fail. So that's a good thing. And we've accomplished our job. We've essentially eliminated one issue that CodePeer identified. We put in some defensive coding. There are various other ways to deal with this, which we could talk about in later videos. But this is the most straightforward way to deal with this particular problem right now. And we'll stop our demonstration here. And what we've seen so far is we've seen how CodePeer can find problems. We were able to use the CodePeer's ability to infer postconditions in this case to try to understand what might be the source of the problem. And it was in this case that the high bound was potentially 0. So we went back and we put it in the defensive coding and save that, rerun, and sure enough, CodePeer has now resolved that particular problem. And by choosing to just look at removed messages, we can quickly identify what's changed. We can also just look at added messages, and sure enough, there is one new low message. And if we choose what that is, well, if we go to that location, we'll find that CodePeer is informing us that there is the possibility that this exception might be raised. So we, of course, wrote that raise statement, and specifically to prevent this later constraint error, which we would consider a more serious failure. And here we will raise an exception that is in fact handled elsewhere in the program. So from our point of view, we're not going to worry about this particular problem for now. And in fact, we could tell CodePeer that this was intentional by clicking here on this review message, and we could say that this is intentional. This is doing exactly what it should do. Put in my initials here, and this exception is handled elsewhere, so not a bug. And we'll just save that. Notice that no longer does it complain, and we're now down to having no added messages, but we still have other messages. So with that, we'll end our demo, and we hope you'll look at later CodePeer videos to see more in-depth demonstrations of CodePeer's capabilities. Thank you very much.